So this entire lesson we've been neglecting a and what it does to the parabola. So in this lesson we're going to go ahead and finally take a look at this. So ax squared, I have it here on Desmos on the right hand side if you take a look. Let me bring it over here. So ax squared, we're going to see what happens. So a currently is 1. What happens if we make it a really large number? Look what happens to that parabola. And that parabola just closes up. It gets narrow. And the reason for that is it's increasing faster and faster. And that's what's going on. So it's blowing up faster and faster. And you can picture as x gets, larger. If we're just going to apply a big number to it and multiply it by some big number, that just means it's going to be an even bigger number. So it's just going to go up faster and faster than before. So, sometimes we think wider from the bigger number because that, for some reason, geometrically makes sense to us. But actually, if, let's just say a is 0.1, it's a really wide parabola because this is suppressing its growth. It's not able to grow as fast as it did before because a is some small number. So it's taking what x squared would normally do, multiplying it by 0.1. So it's just basically holding it back. And that's why it's not able to grow as fast as it normally would, as if it was a large number like this, making it narrow. So right here, it's narrow if the absolute value of a is greater than 1. It's wide if the absolute value of a is less than 1. Now, realize its absolute value of a, because if a is negative, then what happens? It goes upside down. You can see that right here. Look at what happens if I put negative value. Now, all of a sudden, it's flipped. It's upside down because it just takes those positive outputs of x squared and makes them negative, is what it does. So, basically, if a was like 0.5, that's a number less than 1, or 0.3 or 0.9. Those numbers are less than 1. They're what cause it to be compressed and horizontally compressed, because you're going to see what they mean by scaled vertically. Scaled vertically would be making it narrow like this. So let's take a look at a problem here. So the parabola y equals x squared is reflected across the x-axis. So what that means is that it's been flipped like this. And then it's scaled vertically by a factor of 5. So this is going to be negative 5x squared. So quite an easy problem. The parabola x squared is scaled vertically by a factor of 7. This one's not flipped. This is just the regular x squared. It didn't say that it's been reflected across the x-axis. So what we're going to go ahead and do is just put 7x squared. All right, super easy, right, guys? This is a little bit more complicated. So now they're giving us a point. So this right here, the dashed line is g. And that's what we're going to write the equation for. So f is x squared. So what is g going to be? Well, g of x is taking that x squared and multiplying it by some factor a that we need to find. So we're going to solve for a. We're going to figure this out. Well, we know one of the points here is 2, 3. So what I'm going to do is I'm going to plug in the 2 for the x, and this is the y here. G of x is basically the y. You can think of this as y equals. So if we have the point 2, 3, x is 2 and y is 3. So 3 equals 4a, because 2 squared is 4. Divide the 4 to the other side, and a is 3 over 4. Now, that's not the answer. The answer would be 3 over 4x squared. That's what the equation for g would be. So look at this one. Same idea. So our y is ax squared. So we're going to figure out what a is. Now, we're given the point 2, negative 1. So let's plug that in. Kind of similar, 2 squared, 4 again, right? Divide the 4. And so we have negative 1/4 x squared. It makes sense it's going to be negative because it's upside down, right? And that's the idea. And that's all for that assignment.